Okay, good morning, everyone, or good afternoon. I'm Cherry Kubota. I'm a professor at The Ohio State University. Welcome to Indoor Ag Science Cafe in September. We have been doing close to 3 years, I guess, and then it's always exciting to have new topic, learning opportunity around the indoor farming. So thank you very much for your time to share with us. Again, this is a community platform, communication platform to exchange ideas and knowledge about indoor growing. So just wanted to quickly, upcoming schedule, this fall, we are kind of expanding, beyond leafy greens. In terms of business model, in terms of crops to grow. So today we're going to have special speaker, Paul Brown from Purdue University talking about aquaponics. So additional object to consider, I guess. And then next month, we will have Robert Colangelo back to talk about business side, technology side of vertical farms, a little bit of history and future perspective. This is going to be interesting talk, so you can't miss it. And then Andrew Sierra from Farm Shelf will be talking about very unique business model using indoor growing facility or equipment. And then December, we will have Nobuyuki Matoba from University of Louisville talking about plant-made pharmaceutical under controlled environment. So interesting topics are lined up. So please look forward to having those webinars. I'd like to announce one special program we are planning right now for January Cafe, so the first one in 2022. I like to use at least one cafe, or we like to use at least one cafe for technology showcase. So we would like to invite commercial technology providers, vendors, to showcase your new technologies, exciting new technologies around the indoor farming or vertical farming. So each one has 10 minutes. So if we have more companies who are interested in talking about technologies, we will create more than one cafe dedicated for that technology showcase. So please contact me, Cherry Kubota. Just reply to whatever you received, and it should come to me if you are interested. And then we will select and then line up, maybe classify or whatever, but let's see. So just if you're interested in giving 10-minute presentation, please let me know in January. All right, so today's agenda, again, we will have special speaker, Dr. Paul Brown, and then Dr. Carrie Mitchell, who is introducing Dr. Paul Brown. Both are from Purdue University. So I'm stopping sharing while Paul is gonna take over, and then Carrie is introducing.
Okay, well, thank you, Cherry. Again, this is Carrie Mitchell from Purdue University. I'm in the Department of Horticulture and Landscape Architecture. And I believe I started working with Paul Brown. He reminded me the other day, I think about 17 years ago or so, when we were both working on a NASA grant at Purdue, an NSCORT. And what we were actually trying to do was see if we could take crop or plant waste and convert it to feed for fish or food for humans. And we got involved with another group at Alabama that was pre-treating these crop wastes with fungi. And then we were feeding this to, at the time, tilapia fish had a reputation that they could eat anything. And I think that turned out to be a myth, but anyway, we worked on that, had a great time. We developed a reputation of doing that and working together. And then about maybe what, Paul, 8 years ago or so, we were approached by the organizers of the Sustainable Farming Systems curriculum at Purdue, and they asked if we would develop an introductory aquaponics course, which was kind of based a little bit upon what we were trying to do in that NASA grant without actually closing those loops. Paul is in the Department of Forestry and Natural Resources at Purdue, and he's an aquaculturist with a specialization in mineral nutrition. In this course we have developed, we also bring in guest speakers about economics, engineering, and various special technologies. The course is a junior level course. We open it to anyone, and we get everyone. So it becomes very multidisciplinary, and we try to leverage that by taking the breadth of student enrollments and assigning team projects. And then we stand back and we encourage creativity on their part. And it's very interesting. My own knowledge of aquaponics has remained fairly introductory at a fairly basic level. Recently, Paul's knowledge has advanced somewhat since he's begun training graduate students in the integrated aquaponics area. So that's why I want to focus on him today. But by the way, and also by way of introduction, as most of you may know, in aquaponics, fish feed and the resulting fish waste are essentially the sole source of mineral fertilizer for plants. So the plants aren't necessarily getting a complete or proportioned mineral fertilization. And this does require microbial bioprocessing to break down these organics, both for mineralization and as also for the nitrification process that's so important. And when closing the water loop, the plants and the aquatics, whether they're fish or other things, they often have environmental requirements that are not exactly the same, like pH or temperature or nutritional requirements. So these become the research challenges to help make aquaponics more productive, potentially more commercially profitable, and certainly sustainable. And so this is the justification for doing aquaponics research, which Paul Brown has now taken off on. And at this time, I'd like to just turn the microphone and the screen over to Paul, and let's see what he has to say. I'll try to help out with Q&A later as appropriate. Paul.
Thank you, Kerry, and thank you, everyone. It's a pleasure being here with you. This is it's an interesting fora you have here. As I was looking at the participating institutions, I'm thinking, my gosh, this is something we could probably need to do within aquaponics. And we always wonder why we volunteer to do things sometimes, and one of mine great wonders right now is why I volunteered to serve on the board of governors for the Aquaponics Association. Other than try to help them out and make sure that some of our research might be relevant. But they've made me research director now, and the 8 hours a month that they assured me, of course, has developed into something closer to, I don't know, 30 or 40 hours per month. But anyway, it's an interesting group, and it's a very different group from some of the other stakeholder groups that I've worked with over the years. So it's interesting to see the differences as well as some of the similarities. What we're talking about here, and I confirmed this just before we started today, that I assume that I'm meeting with and presenting to a group that is, as Kerry called them, plant-centric. I assumed some knowledge on soilless plant culture and some knowledge of hydroponics. So if we start with that assumption, if that's correct, I tried to keep my presentation today relatively short and a bit focused to give you a kind of an introduction to it. This is the kind of discussion that could be an ongoing one, quite frankly. Be glad to come back and talk about more detailed things if there's interest in the group. But what we're talking about here is adding a system, subsystem to hydroponics or controlled environment food production type of system, and it's going to be an animal subsystem. And it's essentially just an aquaculture system integrated with a hydroponic subsystem. It's that simple. And I typically also immediately follow that up by saying it's that complex. The beauty of the system is that our practitioners with very little knowledge in biology and botany or any of the pertinent scientific disciplines can make these systems work. They can produce foods, they can produce fish, they can produce fruits and vegetables. The list of both plants and animals that people are experimenting with is growing dramatically. All kinds of interesting combinations out there that can be incorporated into this. So it's a simple addition of one additional subsystem, and yet the complexities and the details are poorly understood. But again, the systems do function. So it's an interesting one because we get a wide range of practitioners from backyard people and people with a simple beta in a tank, or a goldfish in a very simple tank, and they're growing some fresh herbs on top of their goldfish tank. So it's really kind of an interesting group. What we're seeing right now is really, I'm going to emphasize, I hope I can emphasize the fact that this is still an emerging type of food production system. The animals that are being raised thus far, I would describe them as extraordinarily limited. And the major species we're seeing remain the tilapia. We're also seeing some rainbow trout, but also some ornamental fishes like koi and goldfish. And for the most part, these are not based on market value or demand in the marketplace. All of them have established industries. So you're competing with large established global industries. It's really because of ease of culture. We're focused on, our practitioners seem to be focused on these species because of ease and the knowledge surrounding these. You can make an argument, of course, that the koi is a highly valuable species, but the really valuable koi are few and far between. And very few of them are actually produced here in North America. It remains largely an Asian type of market. So I emphasize that this is new, and I want to put this in context. We have, every time I see this number, it seems to increase. But we're over 32,000 recognized species of fish on this planet. I wouldn't be surprised if that number is up to 35,000 now. And we've got hundreds of thousands of species of crustaceans. And I'll emphasize here some of our crustacean work towards the end of this. And again, I think, if I'm correct, that the microbiome and the microbial ecology in this integrated system becomes a bit more important than a standalone hydroponics type of system, because we do need a very complex and healthy microbiome to mineralize a lot of nutrients and get them over to the various subsystems, as well as in for the nitrification. The system started from a very simplistic need to detoxify ammonia excreted by the fish. Ammonia is a primary waste product, toxic to fish, not a preferred nitrogen source or form for plants. So we rely on routine, common bacteria to convert ammonia to nitrite and then to nitrate. So this microbial ecology is I think, becomes a bit more important. Our current situation, again, doesn't have a lot of imagination associated with it, quite frankly. They all started off, it seems like, with tilapia and leafy greens. This system works very well. Some of our practitioners have switched over to herbs because herbs are far more valuable in the marketplace. And here's a good example that the standard way to start, and again, it's because of ease of species and a good match, but this is a fundamental thermal mismatch right here. Tilapia is a tropical fish, grows best at about 28 degrees C. Leafy greens, if I recall correctly, are more of a cool weather crop. So we're starting off with neither subsystem really growing optimally or at maximum. And when we look at some of the current systems, the fish have been accurately described as an economic drain. But that only occurs in the very early stages of startup. The fishes that have been chosen thus far, for the most part, like a tilapia, require anywhere from 9 to 12 to 15 months to reach market size. And yet you can harvest plant crops, 4, 5, 6, 8 times during that period. So in the early stages, I think it's an accurate statement to call the fish an economic drain, but over time, it's easy to set up routine harvests, even weekly harvests. And we've seen this in aquaculture companies, they're standalone aquaculture companies. So it's one of these situations where the start can be a bit rough economically, and yet once it gets up and going, it can produce food on a regular weekly basis. Now, again, in aquaculture, we've got tens of thousands of species, but we've got less than 15 major species industries globally. And it's the first time I heard this next phrase that I put here, thousands in developmental stages, I thought it was a bit of an exaggeration. But I actually sat down and started counting up the new species just in titles of published manuscripts. And the thousands is probably now, in my opinion, an underestimate. Anything that's in the water now is being evaluated now as a potential aquaculture species. And they all seem to work to a certain degree with certain nuances and all kinds of interesting new disease issues and eccentricities associated with all these various species. And yet we're going to see, I think, in the future, a great diversification of farm-raised seafood products in the market. The theory behind all this is a simple one. My gosh, this is, it's again, it's a very simplistic type of situation. It's a simple two-tiered food web. It's a plant, animal, in a controlled environment. This is the normal synergies that you would expect in terms of nutrient flows, gaseous exchanges that are all present. We simply take advantage of that simple two-tiered food web. So again, it does work. And again, novice individuals can be successful with these. The animal feed is the primary input, as Carrie mentioned. The animal waste then is the primary source of nutrients for the bacteria and the plants. We've got 3 taxa that we've really got to worry about feeding and providing nutrients for. As much as I worked a lot with some of the fish feed mills around the country and around other parts of the world as well. And no one right now produces a fish diet or aquatic animal diet that you can truly say is geared towards and formulated for meeting the nutrient needs of the bacteria and the plants and the target fish or crustacean. But the systems do work. We also have some very clear nutrient deficiencies that turn up. The solution is to simply add inexpensive, readily available minerals back to the systems, or to put them in the feed. As a highly biased fish nutritionist, I would like to see us be able to put all these minerals back into the feed such that we can feed all 3 disparate taxa in these types of systems. And with a sole single input, then the practitioners don't have to worry about as much about monitoring nutritional deficiencies in plants or the health of the various bacteria they need to raise. Now, the benefit of this over a simple hydroponics system or a standalone hydroponics system is you get multiple crops, therefore multiple revenue streams. And then we argued, I suppose, successfully with NASA that the quality of food produced with this combination of plant and animal was indeed a high quality food for colonization types of efforts. And I'm going to end up here in this presentation pointing out how this might start to fit in with this newer concept of sustainability and the concepts of the locavore demand and fresh food demands. It seems to fit some of those criteria. Bottom line is, just like with hydroponics, we produce more food on less land using less water than traditional food production systems. And when I say this from an aquaponics standpoint, I'm thinking of terrestrial animals and terrestrial plant crops. So again, more food, less land, less water. It seems to make an awful lot of sense for what we need to do in the future. And one of the fundamental questions we always get is, well, what about animal waste as a potential pathogen? We have no animal waste diseases, and I capitalized that last word there, yet. Bacteria have a way of being interesting little critters, mutating, becoming resistant to antibiotics, all these types of interesting things. The E. coli are present in the gastrointestinal tract of fishes and invertebrates, crustaceans, and yet they are not the pathogenic species and strains of E. coli. So as of yet, we have no real disease issues. We have a few other zoonotic bacterial diseases in the aquaculture world, but they're few. There's only let's see, there's probably 3 of them. 2 in salt water and 1 in fresh water. So again, the disease issue is always present. It's always got to be a consideration, but thus far, it hasn't reared its ugly head too badly. And when I come at this, I'm looking at it from a larger perspective. We probably all make use of these types of numbers. The changing, the increasing population plus changing food habits in China and India, FAO projections of almost a doubling of food demand in the next less than 30 years now. That's a bit daunting when I look at those numbers myself. And I think, and I've been an advocate for additional food production systems. And I'm not overly concerned about what form or shape those systems come in, whether it's aquaponics, hydroponics, any type of controlled environment types of approaches. I think all of these we can possibly muster and can possibly, the private sector wants to incorporate. We've got, again, I think we've got a relatively daunting task here in front of us. Our research on the freshwater side of things thus far has been some things you probably not all that familiar with. I've got a very interesting student who's working on a very discrete stage of an aquaponics system, and that's how we start these things up. For example, in the aquaculture world or aquaponics world, we typically use well water. Whereas I understand in hydroponics, you like to start with reverse osmosis water, and you can very carefully and precisely make your nutrient solutions to meet the needs of the target plant crops. So that makes a lot of sense. Well, the fishes don't do well in reverse osmosis water. So they need some ions in that water in order to osmoregulate. So we've been examining that very early discrete stage of it. We've been examining the carbon sources that are necessary for the various bacteria that we need, because the carbon-nitrogen ratios are a bit out of balance with just a single fish feed as the input. And we've also been addressing what we've labeled now the pH conundrum. The nitrification, bacteria that involved in nitrification have a preferred pH range in the environment. And then of course, you folks are intimately familiar with the the fact that nutrient uptake, mineral uptake in plants is a function of environmental pH. Unfortunately, those two pHs are not the same. So we've been looking at just where the balance is, where the best happy medium might be, as well as in recycling some of the inedible plant components back as our carbon sources. So this we've been working in this area on the freshwater side. Then we've also been looking at marine aquaponics, and it's let me emphasize that marine aquaponics is a bit of a misnomer. As you can see in the second bulleted statement there, we're really working in brackish water. About 10 to 15 parts per thousand has been best thus far, whereas full strength seawater is up around a range of 35 parts per thousand. And yet the fishes that, aquatic animals that can tolerate full strength seawater can also tolerate 10 to 15 parts per thousand quite well. And one of the first species from the aquaculture side that was identified as being tolerant of even pure freshwater was the marine shrimp. And these are the same shrimp that you see in the marketplace, major global industries. So it makes an awful lot of sense to work with them because of their growth rates. With marine shrimp, we can get as many as 3 and 4 batch crops per year. So all of a sudden, then we hope that that coupled with some salt tolerant plants starts to produce a system in which the fish or the animal component is not the economic drain. We have an animal product that's going out of the system at a much higher market value, a much higher demand. The 3 plant species we've chosen to look at here in the short term are there in front of you. A very enterprising Taiwanese student. She picked these. They're familiar with, these are familiar plant crops in Asia. And they're working all quite well, quite frankly, at this point. So we've been exploring this and specifically some really fundamental questions, asking what's the optimal salinity for this combination. And again, it was in that brackish water range. The ratios of the subsystems and the flows of nutrients, the carbon nitrogen ratios, and then more specifically looking at the optimal dietary protein in the shrimp feed for this integrated system. And we made some progress enough that looks like we've got a new project now, which will be a year-long production cycle, seeing just what kind of volume we can get over an annual basis with that combination, and to start to understand some of the more targeted markets that aquaculture uses in the North Central region. Live fish sales in the Chicago Asian market have been strong for a long time. There's very little, our fish farmers don't compete in that market with frozen products because that market prefers and demands live fish, live animals. And yet that market is not really well quantified nor well understood. So I'm going to turn loose a couple of my Asian students and go up there and watch them interact with this Asian market. And I'm going to eat a lot of good food while I'm up there, and I hope we get to understand that market much better. But there's an awful lot of opportunities, I think, particularly on the marine side of things, because so many different new species come in, many with good name recognition and many with high market demand. It's the plant side that becomes a bit more problematic once we go to a marine aquaponics or a brackish water system, because well, I started to say so few plants are salt tolerant, and yet we've been pulling together that list now for almost 8 or 9 months now, and the list is actually growing quite long. So there's an awful lot of potential halophytic plant crops that could be grown in these types of systems as well. I see the short-term applications of aquaponics pretty much like this. I'm still intrigued with the whole concept of exoplanet colonization. There was a think tank not too long ago that met with and They were charged with brainstorming and coming up with some recommendations back to NASA on just how food would be produced in this scenario. They've got lots of options. It's unclear now which way NASA or SpaceX or whoever it is going to go. Lots of considerations from payloads to there's just so many different considerations. It's a very complex situation. But again, the quality of food coming out of that type of food production system might be a good one for these types of efforts. I see an awful lot of applications in urban locations, meeting the local board demand, this demand for fresh foods now that we're seeing. I think there's a logical connection with all of the controlled environment food production systems and the concept of smart cities. Everything seems to be focused right now in the smart city complex on such things as public utilities and things like that. But if we could increase the local food production in these areas, we would diminish then the stresses on infrastructure, decrease carbon footprints, things like that. And I think it makes an awful lot of sense that some other groups might pick up and embrace this whole concept of controlled environment food production systems. We are seeing and have been seeing pretty significant development of aquaponics types of systems in water scarce areas, particularly the Middle East. And here you've got a situation in which you not only have water scarcity, but there's an awful lot of displaced peoples over in the Middle East right now. And it seems to be getting worse here just recently. So these camps are both struggling to find water as well as feed all of these peoples that have been displaced. Very quick, simple setups of aquaponic systems provide a lot of food in a very short period of time. I've been keenly interested in developing countries where we simply have a need for high quality foods to this day, which I still find rather disappointing in our world in the 21st century, but that is the case. And again, a simplistic system producing high quality food makes an awful lot of sense for people who simply need food. I've seen with the disruption in supply chains here that occurred here a couple of years ago, I'm seeing an increased interest in simple subsistence food production for households. And there are a couple of our colleagues who are working on that very topic. One recent publication out of a European group claimed that they had a micro aquaponics system that was produced enough food to feed a family of 4 for a year. Get more closely into the calculations, which I shared with our class here last week. Their definition of adequate food for a European family is a bit different than the one we might see in a US market. For example, they produce a lot of fish and tilapia again, 22 different fruits and vegetables, and yet they wound up with 1.5 ounces of fish per person per day. For a US consumer, that's probably adequate, and yet probably not preferred. I make the case with our students that a simple hamburger at a fast food restaurant is what, 4 ounces, a quarter pounder, there you go. So we've got, I was making a point with our students to be careful about seeing claims in an abstract of a published paper, and yet realize also that this is coming and it is a possibility. It all depends then back on consumer expectations. I want to end up with a statement, the first statement that I heard, and it stuck with me then, and it still resonates with me today. And it was with the potential funding agency that we met with many years ago now. And there was a hydroponics research group there who had regular funding from this funding agency, and introduced the topic of, what about aquaponics? And their statement was, and I've got it in quotes there, I think it's I think it's close to being an accurate quote. They said, hydroponics does not need fish. And, you know, I have to acknowledge that that's a correct statement. It's an accurate statement. You don't need fish. Hydroponics works very well as is. The soilless culture, the controlled environment agriculture types of approaches work very well. And I think it's going to be a component of our food production systems in the future. So where's the value in a fish component, an animal subsystem? It gets back to the quality of food. It's also the very high quality protein sources coming out of that system. You've got the whole N3 fatty acid argument then in human health. And then more recently, we've been working with a young colleague in food science over here who's a life cycle assessment specialist. And in one of our very first evaluations, very small scale lab scale kind of comparison, aquaponics compared to hydroponics, 2 times the value of the crops produced, multiple revenue streams, but more importantly, 45% lower environmental impact. And this is this life cycle assessment metrics. They're fascinating to me. They get at the very heart of this concept of sustainability. All kinds of interesting quantitative metrics that can be applied to this. Now, the fundamental question always remains: is the consumer and our practitioners going to pick up on this, and is it of interest to them in their marketing schemes? And I can't predict the future very well. But we are hearing more and more about sustainable food production systems and lower environmental impacts being preferred among U.S. consumers. So we'll see how this all plays out. And I'm a supporter of all of these types of efforts myself. I wanted to end with what many of you are probably sitting there thinking, that quote up top. Because I have to acknowledge that that's probably true. If anything, the fish component needs the plant side to detoxify the nitrogenous waste. But again, then the combination of crops, revenue streams, and quality of food, perhaps that's an argument for the integrated type of system. And with that, I wanted to keep it quick, short. I'm really interested in the discussion that might ensue here. I'm really intrigued by what questions you folks might have or comments you might have.